The game continues as we seek to solve systems of equations. We've learned how to do it by graphing. We've learned how to do it through substitution. Now we're going to learn a third way, and that's called elimination. Now we will have 2 lessons on this for elimination, and they're pretty similar, but we're going to start with a more basic version of elimination, and then in section 6.4 we'll get one that's just a little more complicated. It's just like one extra step, so it's not a lot more complicated. So today we'll talk about using elimination, using addition and subtraction. In a system of equations where the coefficients of the x or the y terms are the same, solve the system by subtracting or adding the equations. So, if the 2 coefficients have different signs, meaning one's negative and one's positive, or vice versa, then you will add the 2 equations. Different, add. If the 2 equations have the same sign, subtract. So you can kind of think of it as you connect the D's. Different, add. Same, subtract. Now we use that S every time, but I do want to help you just remember it that way. Different, add. Same, subtract. So if you remember, when we were solving through algebraic methods, we were doing, in other words, the non-graphing way. We learned substitution, and with substitution, we typically looked for a variable that had no coefficient. Well, as you see in number 1 and number 2 here, every variable has a coefficient. Now in this one, the x's cannot be easily eliminated because this one has a 2 and this one has a 5. But the y's can be pretty easily eliminated because they're both negative 3. Now since they have the same sign, both of them are negative 3, we will subtract the 2 equations. So if you remember, when we were learning to solve for x, we learned, okay, we can add a number to both sides, and that's okay, as long as it's the same number on both sides. We can subtract a number from both sides, multiply both sides by a number, divide both sides by a number. Well, we're also allowed to actually combine equations by adding them or subtracting them. So in this case, since negative 3 and negative 3 have the same sign, we will subtract the 2 equations from each other. And the reason I put parentheses around this second equation is to make sure we remember we are subtracting every one of these terms. So it's 2x minus 5x, which is negative 3x. Negative 3 minus a negative 3 is 0. So the y's actually cancel out. They get eliminated, which is why this method is called elimination. Because negative 3 minus negative 3 is really negative 3 plus 3. So negative 3y plus 3y is 0. So no y's are left. They are eliminated from the problem. So last we do 11 minus 14, and we get negative 3. So by subtracting these 2 equations from each other, we are able to eliminate the y variable, which makes this easy to solve. We can divide both sides by negative 3 and get x is equal to positive 1. Now at this point, the process is identical to what we did with substitution. We can plug 1 into either one of these equations for x and then solve for y. So you can pick whichever one you want. I'll just tend to pick the top one, unless there's a good reason to pick the bottom one instead. But it's okay to do either one. So I plug in 1 for x. 2 times 1 is 2. Subtract 2 from both sides, and I get negative 3y equals 9. Then I divide both sides by negative 3, and I get y equals 3. Negative 3. Negative 3. So our solution to this system of equations is 1, negative 3. Okay, in number 2, we see that the x terms have the same coefficient. Now one is negative and one's negative, one's positive. That's okay. They're both 6 is the point. Whereas 5 and 7 are not the same. So while the y's were easy to eliminate on number 1, it's the x's that'll be easy to eliminate on number 2. And since these have different signs, we will add 6x plus negative 6x is 0. So these two get eliminated, they are canceled out. 5y plus 7y is 12y, and 4 plus 20 is 24. So we eliminated the x's, and that allows us to solve for y. Divide both sides by 12, and we get y equals 2. Then you can plug 2 back into either equation, doesn't matter which one, and that will allow us to figure out what x is equal to. So 5 times 2 is 10. We'll subtract 10 from both sides. We get 6x equals negative 6. We'll divide both sides by 6. So we get x equals negative 1. So the answer to this system of equations, the solution, is the ordered pair negative 1, 2. And make sure when you write the ordered pair, you always put the x on the left, or first, and the y on the right. That may not be the order in which you find them, and that's okay. But you always, in an ordered pair, put the x on the left and the y on the right. Okay, so I'm going to be quiet for just a moment because I want you to just look at number 3 and see if you can figure out whether we should add or subtract the two equations. So we're looking for a variable that has the same coefficient. So that would be the m in this case. And if you're like, which one's x and which one's y? We always go alphabetical. So just like x comes before y, m comes before n in the alphabet. So as far as writing the ordered pair, we'll treat the m like it's x and the n like it's y. But we have 3m, positive 3m, and positive 3m. So since they're the same signs, positive, positive, we will subtract the two equations. 3m minus 3m is 0, so they cancel out. They're eliminated. Negative 4n minus 2n is negative 6n. And then negative 14 minus a negative 2 is really plus 2. So the result is negative 12, because it's really negative 14 plus 2. Then we divide both sides by negative 6. And we get n is equal to positive 2. Because negative 12 divided by negative 6 is positive 2. So now we can plug the 2 in for n in either one of these, doesn't matter which one, to solve for the other variable. So 3m minus 4 times 2 equals negative 14. Gives us 3m minus 8 equals negative 14. We add 8 to both sides. We get 3m equals negative 6. Then we divide both sides by 3 and get m equals negative 2. So remember, go alphabetically, just like x comes before y in the alphabet, m comes before n, so we will write the negative 2 first and the positive 2 second. So negative 2, 2 is the solution to this system of equations. Now again, I'll be quiet for a moment. You can pause if you want longer. But I want you to look at number 4 and think about which variable can we easily eliminate, and should we add or subtract the two equations to make that happen. Okay, so 3 and negative 1 are not the same, so eliminating a would not be easy. But this is positive 1b and negative 1b. So that's the same coefficient, but they do have different signs, so we will add these two equations together in order to make that happen. 3a plus negative 1a is 2a. 1b plus negative 1b cancels out, so the b is eliminated. 1 plus negative 3 is negative 2. So to solve for a, we can quickly just divide both sides by 2. Get a equals negative 1. Now we can solve for b by plugging negative 1 into either equation, doesn't matter which one. You know, I tend to do the top one, but it really doesn't matter either way. So we'll, just a second, I think I may have made a mistake. Let me look. Oh, yes, I did. Sorry. This goes in for A, not for B. My mistake. So I plug -1 in for A in the top equation. So I didn't make the mistake on purpose, but make sure you do plug the number in for the correct variable. So 3 times -1 is -3, plus B equals 1. So then I add 3 to both sides, and I get B is equal to 4. So as I said on number 3, we just go alphabetically. Whatever comes first alphabetically, we put that first in the ordered pair. What comes second goes second in the ordered pair. So -1, 4 is the solution to this differential equation. And since you saw me nearly make a mistake and solve for the wrong thing, if you want to check your answers, you can. You can do that by plugging in -1 for A and 4 for B in the top equation and see if that equals 1. It does. Plug -1 in for A and 4 in for B in the bottom equation, see if that equals -3. It also does. So you can test your answer by plugging it into both equations and seeing if it works out. At number 5, I'll take a brief moment to let you look at number 5 and say, okay, which variable is easiest to eliminate? And should I add or subtract to make that happen? You may be noticing there's a difference here from the ones before. You could actually pretty easily eliminate either the A or the B. Because the A's both have a +3 in front. So since they're the same sign, I could subtract them to make the A be eliminated. But the B's also have a 2 out front. Now they're different signs, so we'd have to add in order to do that. But either way, we can eliminate the 2. So this is truly up to you either way. I'm going to choose the A's, but you could do it the other way. I'm going to choose to eliminate the A's. 3A and 3A are both positive. When they have the same signs, you subtract. 3A minus 3A is 0, so those are eliminated. -2 minus 2 is -4. -13 minus 7 is -20. Now we divide both sides by -4. Get B equals 5. So we have what B is equal to, and we can now use that to solve for A. So just for fun, I'll finally do something different and plug it in the bottom equation. We plug in 5 for B. So we get 3A plus 10 equals 7. I subtract 10 from both sides and get 3A equals -3. Then we divide both sides by 3, and we get A is equal to -1. So the ordered pair that is the solution to this system of equations is -1, 5. And just so you know, if you had chosen to add these two together, it would have eliminated the B's, and you could have still gotten the exact same incorrect answer doing it that way. Those don't come often, but you will see them sometimes where you really could eliminate either one. And usually, one you can eliminate by subtracting, like I did, or you can eliminate the other by adding, which would be to eliminate the B's in this case. Okay, number 6. Hopefully by now you can look at that pretty quickly and see which variable we want to eliminate and which operation to do it. So the x's will be easiest to eliminate this time because the x's both have a 4 as a coefficient. They're both positive, so we have the same sign. So same sign means subtract. 4x minus 4x is 0. So they are canceled out. They are eliminated. -2y minus 4y is -6y. 6 minus 10 is -4. So to solve for y, I'll divide both sides by -6. Now this one is a little tougher. Most will be whole numbers, but I wanted to expose you to at least one where we end up with fractions. So we get y equals 2/3. So now we'll solve for x. And you are allowed to use your calculators on this, so don't freak out. I'll just choose to plug this in the top, my normal method. 4x minus 2 times 2/3 equals 6. This is really 2 over 1. So 2 times 2 is 4. 1 times 3 is 3. Now 6 is the same thing as 18 over 3. And I'm going ahead and converting this because I'm going to add 4/3 to both sides. So to make it so they both have the same denominator, 18 divided by 3 is 6. So 18/3 is the same thing as 6. And 18/3 plus 4/3 is 22/3. Okay, so now we'll have to divide both sides by 4. And we can treat the 4 as a fraction, because 4 is equal to 4 over 1. And to divide by a fraction, you have to multiply by its reciprocal. So we'll change this to 22/3 times 1/4. I can reduce this a little. 4 and 22 are both even, so I can divide them both by 2. So we get 11 times 1, which is 11. And 3 times 2, which is 6. So our x is equal to 11 over 6, and our y is equal to 2/3. I know that one's a little bit tougher, so if you need to pause or rewind and look back at it, please do. As I said, most of the ones you do will be whole numbers, but I want you to be able to be prepared for ones that are fractions, especially when you have your calculator to help you.